I'm so happy that you are learning so much even before the school is teaching you. Or if you are already in high school and you are here to clear your doubts about chemical nomenclature, I'm so happy that you're getting the right knowledge. Today's video, you can say, is like the ultimate thing that any student should know in chemistry. That is converting a chemical reaction into a chemical equation. So today's work is converting word equation to balanced chemical equation. Imagine if you open a chemistry book, there is a chemical equation and you can just read it just like English language. Lot of students hate chemistry. The reason is they see these symbols and formula and they don't like it. And all these students have not learned from Chemistry Express, because here we spend real long time in explaining you every aspect of chemical nomenclature. I'm sure you'll agree with this. When you go to school, you'll realize students who are like just directly going into chemistry, where with them all this is done in 1 or 2 days, they find overwhelmed. They get overwhelmed, they find this overwhelming. Yeah. So that's not going to be the problem with you, right? Because you know the formula. It's all, you can recognize easily. Oh, this is copper sulfate, this is ammonium nitrate, this is silver chloride. Yeah. So my intention is, by this video you should be able to read the chemical equations just like you read English. Okay. Now, is it possible? Yes, it is possible. It's great to get super comfortable with symbols and formulae. Once you are super comfortable with formulae, you will be able to read the formula just like English language. But we need a lot of practice. Now, how do you get this practice? When you did so many formula making questions, when you have balanced the equation, you have seen the formula. And also we have a list of common formula. And today's session that I am going to deal with a topic which we have a lot of practice worksheets. So when you will do practice worksheets on today's learnings, you will get super comfortable in reading chemical equations. Now, what is the correct way to learn chemical equation? You know how students will learn chemical equation? They will say H2 plus O2 gives you H2O, or 2H2 plus O2 gives you 2H2O, or Al plus 3Cl2 gives you 2AlCl3. I mean, they're just trying to read the symbols. Don't read that. Don't read like that. First, understand the chemical change. That is, I'll give you one example. We are going to see some examples also. If I take a flask of water and if in that I add sodium. So flask of water, I add sodium. The observation is we will get some violent reaction and you will get sodium hydroxide and hydrogen. How is the equation? The equation is NaOH. So sorry, the equation is Na plus H2O. Equation is Na, which is sodium, plus H2O will give you NaOH plus H2. So this is the skeletal equation. Na plus H2O gives you NaOH plus H2. Now imagine if you're just going to read this equation like that. I'm going to like annotate here and show you. It is not making any sense if you're going to read it like this. So we have Na, then we have H2O, okay, gives you NaOH and H2. Now let me change the color. This might be too light for you to see. Here is a color, okay? And let us say if we want to balance this equation, balancing, you know what, odd even rules of hydrogens I'm balancing first by making this 2, sodium 2 and water 2. You know the steps of balancing. So I'm not going to explain balancing here. Now, you know what students do? They will learn this equation in words, and there are a lot of, like, with due regards to all the teachers, but some teachers feel that you should be so masterful, they ask you to write this equation 10 times, 20 times. I have a little different way. I say that understand the chemical change. Understand, oh, sodium is added to water. Okay. Even if you don't know the observation, sodium is added to water. Okay. When sodium is added to water, you are getting sodium hydroxide and there is hydrogen gas which is released. You'll try to visualize it. You will try to read the reaction around it and you are now set. What happens when sodium is added to water? Oh, ma'am, you get sodium hydroxide and hydrogen. So, note the observations or any special feature of this chemical reaction. This chemical reaction special feature is the violent reaction. And I'm telling you, you should check a video on YouTube on this. There are so many videos. So, they take water and drop sodium. Sodium starts darting on the, like dancing on the surface and it also sometimes catches fire and burns with a golden yellow flame. Spectacular, isn't it? So note the observations or any special feature of the chemical reaction. Then, as I said, don't remember the formula, just say the name. Say the name. So we'll say sodium and water gives you sodium hydroxide and hydrogen. Learn the chemical change in the form of word equation, sodium plus water, once again. And then you know how to convert a word equation into a balanced chemical equation. Okay. I hope you got whatever I said just now. If you haven't, please revisit this segment and you will get it, because next we are going to get into the examples. Before even we go into the example, I want to show you once again the important formula that we will require. These are the common formula I already gave you. Yeah, you will be also having a PDF of this, because I told you to take screenshot. There is also PDF attached with the video. You should have this all the time in front of you, either in the form of a Google Doc or in the form of the written work. Written is compulsory, but even if you don't have the written work, maybe say you're traveling to some place, you should at least have it in a Google Doc. So you know that all the metals are single atom. The formula is also same as the symbol. Then I told you 7 diatomics, hydrogen, oxygen, nitrogen, hydrogen, oxygen, and honestly, FClBri, first class biryani I ate, first class brownie I ate. Yeah. So oxygen, hydrogen, oxygen, nitrogen, and fluorine, chlorine, bromine, iodine are diatomics. Only these 7 diatomics in the entire periodic table. Apart from all that, we write the other elements in the single atomic state. Okay. Then you know that chemical compounds which are covalent, you need to know the names as it is, like nitric acid, sulfuric acid, hydrochloric acid. Don't need to make the formula, just remember the formula. And for ionic compounds, you need to make the formula, because ionic compounds can be 100, 120. You don't have to remember them. Suppose I tell you, give me the formula of zinc chloride. Zinc chloride. Immediately you will look at the positive chart, zinc ion, chloride ion, put it together with Zn2 plus and Cl minus. Zn2 plus and Cl minus, they are not matching. So you will have to do crisscross. For, remember non-compatible ions, we do crisscross. So this is how you'll get the formula for any ionic compound. Okay, and you know that if the ionic compound contains polyatomic ion, then you have to put parentheses. I'm repeating all these rules here because maybe you are looking at this video after a long time and you don't remember, so just kind of revising for you. Along with that, I also want to give you some compounds which are like commercial names are given. These are not important, just for your reference. Okay, if at all you have like something like alum, like can you say K2SO4, Al2SO4 thrice and 24H2O? You can always Google it. Okay, but just for reference, I have given you this. Most important is this table. Okay, now let's start with examples. Let us say I want to write the reaction in the form of a chemical equation. Now the reaction is hydrogen combines with oxygen to form water. What is the reaction? Hydrogen combines with oxygen to form water. You can actually go and find out what is the observation for this. And let me tell you, hydrogen gas, oxygen gas, they react only if there is electricity. So hydrogen gas, oxygen gas react and they give you water. So we are going to extract the reactants and products from this statement and write it as a chemical equation in the form of words. So hydrogen plus oxygen arrow water. This is called as a yield arrow. Hydrogen plus oxygen gives water. Okay. Now the skeletal equation means converting just that word into a formula. Hydrogen is a diatomic, we write H2. Oxygen is a diatomic, we write O2. And then yield arrow, water is a compound, we know the formula H2O. So we got a skeletal equation using only the formula. Last step is to balance it. How do we balance? We will look at balancing first. So let us see, if you just look up here, oxygen is 1 on the right side and 2 on the left side. I'll just put 2 here. So oxygen is balanced, then hydrogen became 4. I put 2 here and hydrogen becomes 4 on both the sides. This is how we balance. So we already know balancing. One more example. So let me see if this video works. Okay, never mind. I told you, right? We are having a very spectacular reaction when sodium reacts with, okay, where do I have? Sodium reacts with water. So if you put one piece of sodium in water, what's going to happen? It starts jumping on the surface of the water, giving a hiss sound, forming sodium hydroxide. In the solution, hydrogen gas is released, and when hydrogen gas is released, so much of heat is there, it burns sodium, and sodium burns with a golden yellow flame. Okay, spectacular. Now what we are going to do is, in all this information along with observation that is given here, we are going to extract the reactant and the product. The reactant are very clearly sodium and water. So I am writing sodium plus water. Products are sodium hydroxide and hydrogen gas. We just write hydrogen, no problem. Now we are going to convert this word equation to skeletal equation. So sodium, monoatomic. I told you all metals are monoatomic, right? Only Na. No charge on it. It's not an ion. It is simply sodium. See, if it was sodium nitrate, sodium chloride, sodium phosphate, then we would have written Na plus. Na when combined with something is an ion. So you write only Na, water is H2O, and then sodium hydroxide. Let me just change this O. I think I put 0. Yeah. Oops. Yeah. And I'm going to like, okay, perfect. I'm a little OCD. So Na plus H2O gives you NaOH and H2. This is a skeletal equation. I told you hydrogen is a diatomic. Now we are to balance the equation. You know how to balance? We'll put 2 in front of NaOH because hydrogen is odd on the right side. Then we make 2 Na to balance out Na, and finally we put 2 here to balance the hydrogens because hydrogen is 4 on the right, so it should be 4 on the left as well. Okay, and one last example is carbon dioxide is passed through lime water. Let me show you this video. Let's see if is it work? Yeah. So there is like little transparent, slightly transparent carbon dioxide. When you blow in it, it turns the solution milky. Okay, carbon dioxide when passed through lime water, which is like little bit translucent, not completely opaque, when you blow carbon dioxide into it, it turns the whole solution milky. Okay, and because there is a formation of insoluble calcium carbonate. Again, don't worry, we are just going to extract the reactants and the products. So the reactants are lime water and carbon dioxide. Lime water is calcium hydroxide. So we don't write the commercial name, we write the chemical name. So calcium hydroxide plus carbon dioxide gives you calcium carbonate and water. Okay. Now we will convert it into skeletal equation, calcium hydroxide formula using ionic formula, making calcium Ca2 plus OH minus, and when you crisscross you get this formula CaOH twice. Carbon dioxide is one of the important compounds we learned, CO2. Calcium carbonate, again we will use formula making Ca2 plus, CO3 2 minus, Ca2 plus and CO3 2 minus. 2 plus 2 minus are compatible. Just write them without the charges. So it is CaCO3 plus H2O. See students, at this point if you feel that I'm not able to understand formula, ma'am, I don't know what you are saying, I request you to go back and watch the formula making video. You have formula making part 1, formula making part 2. You can go through both the videos. Okay, if you want you can go in like faster speed, but look at both the videos, then you will be even clear. Okay, then we have to balance the equation. Now you see that this equation is already balanced. How? If you see on the left, we have 2 hydrogens, right? Also 2 hydrogens, 1, and we have got 4 oxygens on the left, 4 oxygens on the right, 1 calcium on the left, 1 calcium on the right. Since it's already balanced, skeletal equation and balanced equation is the same. Super, super, super cool. Guys, you are really, really awesome. If you have reached here, I have tremendous respect for you that you have taken all the efforts to create strong foundation in chemistry. And dear students, the way you are building your foundation in chemistry, now you'll get a little idea how to create great foundation in biology and physics as well. There are more examples given in the PDF, okay? And you should practice doing it. If you want, watch this video one more time. Also come into our inner circle call. We'll be doing more practice questions live when we meet in the inner circle call. Comment your learning. Comment your learning about the entire session, how it was. And if there are any challenges that you came across, you thought that this was done faster, this is to be done slower, let me know. You can email me and we'll include that in our forthcoming videos and in our inner circle recharge call. Now along then, I'm going to wait for you to write your comments, okay? And I'm going to personally read the comments. I told you most engaging comment or the student who is really taking efforts to share their learnings is going to win some good prize from us. So that's all for today. That's all for this video.